SpaceX successfully completed its first launch of 2022, kicking off the company's most ambitious annual launch manifest in history and marking the world's first orbital launch of the year. On January 6, a Falcon 9 rocket lifted off from Launch Complex 39A at the Kennedy Space Center in Florida on a mission designated Starlink 4-5 by SpaceX. Approximately 9 minutes after liftoff, the rocket's first stage returned to Earth and touched down on the deck of SpaceX's drone ship. The booster completed its fourth flight, having previously been used for 2 GPS-3 satellite launches and the Inspiration 4 commercial Crew Dragon mission. The rocket took an unusual southeastern trajectory during the flight to avoid flying over any populated areas, rather than the northeastern trajectory used for previous Starlink launches from Florida. This trajectory, known as the dogleg maneuver, is one of the reasons why SpaceX is launching fewer Starlink satellites on this mission than on previous launches. The payload of 49 Starlink satellites separated from the upper stage 15.5 minutes after liftoff, but because of a lack of ground station coverage, confirmation of the separation did not take place until about an hour later. Following payload separation, the satellites will slowly raise their orbit until they reach an operational altitude of 540 kilometers at an inclination of 53.2 degrees. Thursday's flight continues SpaceX's efforts to expand and upgrade its Starlink internet constellation, marking the 35th dedicated Starlink launch since 2019. This launch brings the total number of Starlink satellites to almost 2,000. It also continues the company's efforts to launch newly upgraded satellites equipped with special laser links. This way, the satellites can communicate more effectively without relying on ground relays. In addition, Thursday's launch marked the start of another action-packed year for SpaceX. In 2021, SpaceX set a new record for most launches in a single year at 31. SpaceX will try to keep up its rapid launch cadence this year as it continues to expand its ever-growing internet constellation. The next Falcon 9 mission this month is the company's third dedicated rideshare mission, Transporter-3, to a sun-synchronous orbit with dozens of small microsatellites and nanosatellites for commercial and government customers. Following that launch on January 13, the company will also send a radar reconnaissance satellite into space for the Italian space agency, called Cosmos SkyMed second generation. The satellite is scheduled to launch on January 24. 2 weeks ago, James Webb Space Telescope, the most powerful space observatory ever built, roared into the sky, carrying the hopes and dreams of a generation of astronomers. On Saturday, January 8, the observatory unfolded the last section of its primary mirror, bringing the light-collecting structure up to its full size. Nearly 3 hours later, engineers sent commands to latch those mirrors into place, a step that amounted to it becoming fully deployed. Webb's mirror deployment was a multi-step process. On Wednesday, January 5, the mission team locked into place the observatory's 74 centimeters wide secondary mirror, the second surface that deep space photons will hit on their way to Webb's 4 scientific instruments. 2 days later, on January 7, the observatory deployed and latched the left-hand wing of its primary mirror. The deployment of the right-hand wing was completed the next day. Fully deployed, the primary mirror now stretches 6.5 meters across. All of these deployment steps have taken place while Webb cruises toward its final destination, a gravitationally stable spot about 1.5 million kilometers from our planet, called the Earth-Sun Lagrange point. About 29 days after launch, or around January 23, Webb will perform an engine burn that puts it into orbit around the second Lagrange point. But the telescope won't be ready to start observing yet. The mission team will still have to check out and calibrate Webb's 4 scientific instruments and tweak the arrangement of the 18 individual mirror segments, each of which is controlled by 7 actuators. The team will continue adjusting the mirror segments throughout the 5-month commissioning process, which will turn Webb's view from a patchwork of 18 frames into one smooth image. If all goes according to plan, Webb will begin its highly anticipated science mission in late June or early July and keep observing the cosmos for more than 10 years. While scientists celebrated the successful launch and deployment of the James Webb Space Telescope, NASA had another thing to bring cheer in the new year: the extension of the International Space Station from 2025 through 2030. NASA Administrator Bill Nelson was directed by the Biden-Harris administration to work with the agency's partners, including the European Space Agency, Canadian Space Agency, Japan Aerospace Exploration Agency, and Russia's Federal Space Corporation Roscosmos, to enable the International Space Station's use throughout the rest of this decade. ESA has previously voiced support for extending operations through 2030, while Roscosmos has proposed leaving the partnership in 2025 to deploy its own space station. But at the same time, the agency recently attached a new multipurpose laboratory module, (NACA), and a new docking port, (PRICHL), to its segment of the International Space Station. First established in 1998, the International Space Station has been home to a continuous series of expedition crews for more than 23 years. As a microgravity laboratory, the station has hosted more than 3,000 research investigations from over 4,200 researchers worldwide. Nearly 110 countries and areas have participated in activities aboard the space station, including more than 1.5 million students per year in outreach activities. Earlier funded for use through 2024, NASA has been seeking ways to hand over its day-to-day operations of the space station to commercial entities to free up appropriations for its Artemis program of crewed lunar exploration. The extension will also provide more time to ensure a seamless handover of low Earth orbit research and commercial activities from the International Space Station to new private outposts. On January 6, China's Tiangong space station conducted a test using its robotic arm to reposition the Tianzhou-2 cargo spaceship. Tianzhou-2 had been connected to the station's Tianhe core module and was undocked before the test started. The arm secured the robotic cargo craft at 6:12 a.m. China time and moved it to a new position. After moving the ship to a predetermined position, the arm reversed the maneuvers to bring it back to its original position. The cargo craft re-docked with Tianhe, finishing the 47-minute test at 6:59 a.m. 2 days later, on January 8, Shenzhou 13 astronauts inside the station completed a manual rendezvous and docking experiment with the cargo craft. At the beginning of the experiment, the astronauts in the core module tele-operated the Tianzhou-2 cargo craft to leave the front docking port of the core module and move to the planned parking point with the coordination of ground control engineers. After a short stay in the parking point, the cargo craft moved towards the space station complex and completed the rendezvous and docking by the tele-operation of astronauts. The experiment took about 2 hours to complete. The experiment was the first time Chinese astronauts used manual tele-operation equipment to operate the cargo craft and the space station to conduct rendezvous and docking. According to the agency, the robotic and manual docking tests achieved their goal of verifying the repositioning procedures and provided additional experience that will be used in the next steps of Tiangong's construction in orbit. Upon its completion at the end of this year, Tiangong will consist of 3 main modules and will have a combined weight of nearly 70 metric tons. The station is scheduled to operate for 15 years in a low Earth orbit, about 400 kilometers above the planet. Now, let's discuss some of the major Starship updates from the past week. Last week, SpaceX conducted a series of tests and movement checks on the Super Heavy booster catching arms. Built out of heavy-duty steel pipe and measuring more than 30 meters long, the clamp-like arms are designed to stack Starship atop the gigantic Super Heavy rocket, as well as catch the launch vehicles soon after delivering payload to orbit. On 3 January, SpaceX used the drawworks mechanism to move the arms up and down the tower a few meters. Although this was the first time the arms were moved along the rails installed on the tower pillars, this was not the first time SpaceX activated these catching arms. Previously, on 28 October 2021, SpaceX tested the arms' lateral movement by swinging them to the left relative to the tower. SpaceX continued the catching arm tests on 4 January. On Tuesday evening, SpaceX lifted the arm carriage about 15 meters, several times higher than January 3 test. Several hours later, SpaceX fired up each arm's main hydraulic actuator and opened them as wide as they could move. Later, the arms were closed and the carriage was lowered to the tower's lower stop. Similar movement tests were also conducted on Friday, January 7. Last week's chopstick tests determined the arm's full range of motion and ensured that they could be safely controlled. The movement test was a significant milestone for the tower's main arms, and it guarantees that more extensive tests and simulations will be conducted in the near future. Starship Quick Disconnect mechanism was also put to the test last week. On January 4, the stabilizing claws of the QD arm were activated for movement test. This extension will keep the Starship and the booster stable during the fueling process. Shock-absorbing plates were installed on the claws 3 days later to better stabilize the launch vehicles during fueling and dampen shock impulses that would occur when the QD arm makes contact with the ship. The scaffoldings between the catching arm and the QD arm have now been completely removed, paving the way for the chopsticks to move towards the QD arm. With the removal of Booster 4 from the orbital launch mount on December 30, workers are now focused on completing the pending works on the launch platform. Blast shields were recently installed on the launch mount to protect the launch platform's exposed hydraulic plumbing and electrical connections from the shock wave and thousands of degrees plumes generated during liftoff. A full-speed retract test on the Super Heavy Quick Disconnect mechanism attached to the launch mount was also conducted last week. This demonstrated how the QD mechanism will move forward to attach to the booster for fuel supply and how it will rapidly shift away from the booster just before liftoff to avoid its sensitive components being practically incinerated during launch. Last week saw no significant ground tests of Starship 20 or Booster 4. But groundwork still continue on the launch vehicles, and the hardpoints on Ship 20's nose cone removed in December have now been reinstalled. As a result, it is safe to assume that the ship will be lifted from the suborbital launch pad using a crane attached to the nose cone hardpoints rather than the lifting points under the forward flaps. SpaceX is currently working on a new and improved variant of Raptor engines, known as Raptor-2. This is the third-generation Raptor engine after Raptor version 1 and 1.5. According to Musk, Raptor-2 now operates routinely at 300 bar main chamber pressure as SpaceX ramps up ground testing of the upgraded engine variant. On 10 February 2019, just days after SpaceX began testing the first full-scale Raptor prototype ever completed, the engine briefly reached a main combustion chamber pressure of 268.9 bar, breaking records set by Russia's RD-180 engine. 18 months later, Musk revealed that at least one Raptor prototype sustained such high chamber pressures over a minute or more of steady-state operations. The engine peaked at an impressive 330 bar, briefly producing 225 tons of thrust. 14 months later, on 24 October 2021, Musk tweeted that during a static fire test, Raptor version 2 engine reached a chamber pressure of 321 bar and briefly produced around 245 tons of thrust before destroying itself. Now, a little over 2 months later, Musk says the Raptor 2 prototypes are routinely operating at 300 bar without major issues, implying that they can ignite and safely shut down after several minutes of burning at those pressures. Therefore, we can assume that the first Raptor 2 engines are only a few months away from being ready for orbital missions. Moving on to other Starship updates, SpaceX has begun dismantling the oxygen tank section of Booster 3, which is currently resting on Starship suborbital launch pad A. This will free up Pad A to perform ground tests of future Starship prototypes that will be transported to the launch site. Elon Musk confirmed in a recent tweet that, beginning with Starship 24, the methane header tank will be relocated to the nose cone, adjacent to the oxygen header tank. This is to counter the weight of the extended tanks and the 9 Raptor engines on the future Starship prototypes. The new wide bay is growing near the existing high bay, and more wall sections were added last week. With this, we have covered all the major updates from last week. Please share your thoughts on the latest science news and Starship updates in the comments section. Also, do not forget to subscribe to the channel for more weekly updates. And as always, thanks for watching.